Hey everybody, today I'm going to show you a quick tutorial on how to align a mill scan to a CAD model inside of Geomagic Control X. If you can see on the screen here, I've got my input data shown, just the CAD model and the scan data, and it's really tough to see them on the screen. And the reason for that is because they are so misaligned right now that it's tough to keep them both in frame. They're like a kilometer away from one another just because of the way that the scan data was collected. If I hide my scan data and I use the menu view, zoom, fit option here, I can get a nice image of the CAD model of the mill that I'm going to be aligning to. And if I do the same thing, hide my scan data, and the Control F key will take me to my CAD or scan model, I can see the data that I'm going to be using to do my alignment here. So I'm going to create a new result data, and I'm going to add both of these objects to it, which typically will happen when you import something anyways, but I had to delete a result object, so no big deal. Just going to add both of my data to this group. I've got my scan, I've got my CAD, I've got my scan. And the first thing that I'm going to do is I'm just going to hide my measured data. I'm going to do a couple things on my CAD first. So back to Control F here. First thing I'm going to do is I'm going to actually create my central vector. In that case, it's going to be vector by definition method. And I'm just going to put 0 values into all of my position and click on the, let's see, X, to place an axis that goes directly down the center line of my mill here. I'm also going to go into preferences, and I'm going to disable 2 options in here. The reason that I'm going to do this is strictly from a computational time standpoint. These options here will automatically, they will automatically find a pair on the scan data to every CAD face on the CAD model. And that's great. That's really good for small mechanical parts, but it's not great for long-range scan data here, especially when we've got really big, large files. So the tools that I'm going to use are just going to kind of create this pairing more manually. So I'm going to hit apply and OK, and I'm going to use basically 3 objects for my scan to CAD alignment. One of them is going to be that vector. The other one, if I looked at my scan data, I could recognize that this face also shows up in my scan data, so I can use that, or maybe I can use like that cone section there. And the third thing that I need to do is figure out how to kind of index this thing, and I can do that in a couple of different directions, but I'm gonna try just a best fit as it is. So I've got a plane and I've got an axis that I can at least start working with. So I'm going to hide my CAD model for the time being, go into my measured data here, hide this guy, and use Control F to bring up my scan data. So first thing I'm going to do is I'm going to add a reference plane on my measured geometry by just selecting basically all of this stuff here. So hit extract and hit preview, and I get a little preview plane there. Next thing I'm going to do is I am going to create a cross section in my dimensions tab here. I'm going to go into 2D GD&T, and I'm going to add a offset cross section from this base plane. Now I know that this base plane that I created is more or less perfectly, normal to the axis of rotation of this mill. So if I offset this, say, I don't know, 3,000 millimeters, maybe a little bit more, what I want to do is I want to be able to extract a circle from a cross section here. So maybe we'll do like 4,500 millimeters. good enough. Well, let's do 4,000. I want to take two circles, one at kind of either end of this thing. One around here, one around here. The further away that I get, say 3,500, the more accurate that the axis that I'm going to use these circles for to extract, the more accurate that's going to be. So I'm going to hit OK, and it gives me this really ugly view here because it's trying to section both my scan data and my CAD model, which is not aligned, so I don't really care about this right now. I'm going to turn off the reference section visibility, and this is actually really important to do. And then when I turn that off, I can zoom in on just the scan data cross section. Looks like that. I'm going to discard that for the time being, just accept it, and then use the same tool to add another one based off of that plane. This time I'm going to do like 7,000 maybe millimeters. How about 10,000? Maybe that's a little too far. There we go. That looks nice. Okay, so I got another cross section right at the other end here. I can add a third one for accuracy if I want to, but it's not entirely necessary. So here's my cross section there. I need to turn off the reference section because I don't want to be able to make any selections. And now I can actually make a selection on these pieces of scan data. So here's the trick to getting this alignment to work right. I'm going to exit the mode, and then I'm going to just hide my measured data for the time being, but I can still see my two sections. What I'm going to do is I'm going to go into my Home tab, and I'm going to create a construction circle. And for this construction circle, I'm going to make a selection on all of this data here. Now I've got a small problem, and hopefully in a hotfix we can fix this, but right now, besides just all these vertices and edges and stuff that I've got as my selection, I've also got just the entire cross section itself selected, and I don't know how to change that, but I need to delete this guy here, and when I do that, I need this object to be this axis to be located under my measured group, because I'm going to pair this axis here that I've extracted from my scan data with the vector that I created from my x-axis earlier, z-axis or whatever it was. So what I'm going to do is I'm going to make a selection on all that data like you saw me do, change my method here to extract, and when I hit preview I can see that I've got an extracted plane. Or sorry, not an extracted plane, an extracted circle. And I've done a little bit of outlier removal here, and that's going to hopefully make this a little bit more accurate. If I do enough of it, like, I don't know, play with my sigma values here, I can make it sort of start to ignore these dips, these grooves between, or these risers, whatever you want to call them here, and just extract it from these top surfaces. Now I could also just manually go around and click boom, 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 and this is obviously nice and time consuming, but I can ignore some of the other pieces of data as well. So however you really want to do this, it's kind of up to you. Don't really care. This seems to not be taking that much time. Just selecting these cross-section updates. Now, again, I'm not going to be able to do any of that. I'm not going to be able to make any of those selections on my section here until I turn off the reference section view. So again, let me close out of the tool here. See, this is cross section 2. If I turn on reference section and I go into my circle tool and I try and select all this stuff, hey, it's only allowing me to create measured geometry no matter what I select here, which is just not good enough, or it's not going to get us what we want. So for some reason, as long as I turn off that, gotta get out of the tool here, turn off my cross section reference section visibility, now when I go into that circle tool, select extract, select all this stuff. It says define measured geometry. That's really the only place where the trick is. From there, I'm just going to use the 2 center points of those circles to create a new vector. Vector from both of those guys. It defaults to pick multiple points. Again, this vector here is define measured geometry. If it says define reference geometry, you've done something wrong. So I'll build that vector. I've got my plane, so I've got 5 of the 6 degrees of freedom figured out here. The only one I don't have is a rotational one, so I could figure out maybe how to utilize one of these lifters, or what I'm going to hopefully be able to do in a second here is actually do a best fit to lock down my last degree of freedom. So to make my alignment, I'm going to need to do a datum alignment first. And in order to create a datum alignment, I need to pair this plane with that one CAD face that I selected earlier, and I need to pair this vector with that vector. So I'm going to hide my measured data and the measured construction geometry in both of these sections here. And I'm going to go up to my reference data, show it and the construction geometry, and zoom fit so I can see everything in my window. By the way, fun fact, right click your vector here, edit annotation style, and change it to a label, and you don't get that stupid annotation that pops up automatically. I hate that. Alright, so what I'm going to do here is I'm going to go into my pairing manager, and I'm going to select, since I don't have automatically generated scan to CAD pairs, I'm going to select my reference entity first, which is going to be this face. And I'm going to select define measured geometry manually, and I'm going to select my measured entity here, which was that same plane way over there. And then I'm going to hit OK. And then I'm going to do the same thing. I'm going to say my reference vector, manually define the pair is that vector that I kind of extracted manually earlier, and hit OK. And then I can close out of the tool. Now that they've been paired, I can go back to my datum alignment, skip that warning, and I can say my most important data pair is that vector. Second most important datum pair is that face. And when I show my scan data, you should be able to see that it's moving around. I've established a relationship, that second relationship that was wrong. So I need to flip my plane. Actually, I don't. I need to flip my vector. There we go. To get the normal correct. So I've used that plane to establish the shift along the x-axis here. I've used my x-axis to align these two parts exactly. The only thing that I don't have is my last degree of freedom, my rotational degree of freedom locked down, and I can see that I've got, you know, a little bit of overlap over here, and I can still rotate about my x-axis. I can't do anything about that in the datum alignment, unfortunately, so I'm going to have to accept that alignment. And then I don't need to rebuild those two guys. I don't really care. But to finish my alignment here, I'm going to go into my best fit alignment now that these things have been kind of pre-aligned, and I'm going to lock my translation in X, Y, and Z because I don't want it to move. All I want is for it to be able to float and rotate about that x-axis. I don't want it to rotate about the y or the z. I'm just going to give it 1 degree of freedom, and hopefully what we should see is this mismatch here. We should see that shift over a little bit. So I'm going to hit OK, and let's take a look and see if that's able to work. Boom. Cool. So that's pretty good. I'm pretty happy with that. At this point, I don't know if I can delete these two guys or not. Probably should. I don't know if that's going to affect my alignment. No, it's not. Okay, so that's fine. We can delete both of those guys. And that gets rid of my rebuild here. I don't want to be rebuilding those things in my new scan to CAD orientation. They're just kind of reference used for the alignment. Alright, so I'm going to hide my datum alignment here, and then I'm going to just do a real basic 2D compare on my x-axis, and I want to sort of validate the quality of my alignment here. I'm just going to do that with a 2D comparison. So throw something right down the center of the part. Always with mils here, we need to change this number, max deviation, anytime we run a 2D or 3D comparison, because this is a wear scenario where we're going to have a lot more deviation than the software is initially looking for. So if I change this to something like 50 millimeters, oops, I'm going to see a lot more of my deviation. If I change this back to 5 like it's initially giving me, I'm starting to lose areas where I have more than that amount of deviation. So 50 is typically fine. If I expect to see more than 50 millimeters deviation, you know, change it to the maximum, so maybe 100 millimeters or something. And then when I hit next stage, what I want to see is I want to see if the deviation right here right around 4, 5, 6 millimeters pretty much everywhere on all of these guys, top and bottom. And if that's the case, then you know we've got about, you know, we're pretty close to being aligned, pretty well aligned. So that does it. Go ahead and do your analysis from there. Hope you enjoyed the video.